Hi, class. Welcome to an example problem for Unit 6.2. In Unit 6.2, we learn about the method of sections, which is sort of an alternative to the method of joints that we can use when we want to solve just for a handful or for some specific um, forces and members within a truss. So to illustrate this problem, I'm using problem 6-47 from the 13th edition of the book that looks sort of like this guy. And you can see this is sort of an ugly truss. There's a lot going on. If somebody were to tell me to solve for all the forces in this guy using the method of joints, I would recoil. I would just feel sick because this would take me forever, right? There's so many members. I've done a pretty poor job of drawing up around the board, but you get the idea. So we have this big old ugly truss. It's supported on this end by a pin and on this side by a pin roller. And it has these four forces acting on it at the bottom. The idea is that each of these are supposed to be spaced evenly at 2 meters. It does not look that way from how I've drawn it. Sorry. And then it's a total of 4 meters tall. And what we're asked to find is they want us to identify all the zero force members and to find the force in the members EF right here, EP, which is right here, and LK, which is up here. So we aren't being asked to find all the forces, just those three specific ones. So the process with these sort of problems, we start out the same as with the method of joints. We're going to find our zero force members, and we're going to find our reaction forces first. So zero force members, let's look for them. There's quite a few in this one, and it's the same rules for finding them as before, which is if there's any dangly bits where there's only, if there's a joint where there are only two members that are not collinear and there's not a force acting on it, and that's a zero force member. Or if we have a joint where there are three members, but two of them are collinear, and something like this, and the third one is not, then that third one must be a zero force member. So this sort of a thing, or if there's something like this with no force acting on, then in that case both of them are zero force members. So these are the sort of conditions we're looking for. So let's see if we can find them. So I see an example of this right here on HJ. At this IH, HG, those are collinear. HJ is not. And now that that one's not, then the same condition actually applies for JG, because IJ and JK are collinear, but JG is not. And since HJ is gone, right? Once you identify the zero force member, it's effectively gone. So that is also a zero force member. Let's see, so that doesn't work. This one doesn't work. That one would work if there wasn't this force applied right here. But because there's the force here, it doesn't work. Or FP there. Let's see. LE, right? Up here at joint L, we have that condition. So LE is a zero force member. Then let's see over here. So DO, same condition. And just like over there, now that DO is gone, the same thing applies for OC here. And then same sort of thing here. So BN. And then again, because BN is gone, now the same condition applies for NC. Those are all the ones that I was able to find. So, but I mean, that's 1, 2, 3, 4, 5, 6, 7. So 7 of these guys are zero force members that we can just effectively cut out. So let's just go ahead and consider that. So EN, NC, CO, OD, LE, J, G, and J, H, are zero force numbers. All right. So that's first part. So now let's find the our reaction stuff. So we have these three reaction forces, AX, AY, and IY. Again, there's no IX because this is a roller, and a roller, right, it's going to move freely in the X direction. So we're going to solve for IY first by taking the moment about point A. So we do the sum of the moments about point A. So we end up getting, so we have to look at all these forces. So we get -2, that's negative, so -2 times 4, -5 times 1, 2, 3, 4, 8, -3 times 10. And again, the sign, I'm determining the sign whether that's positive or negative by the right hand rule, not by the fact that it's not just because it's pointing down. -2 times 12 and plus IY times 16. So I can do all that math and end up getting that IY equals 6.375 kilonewtons. All right. Now I can just do my sum of forces in Y. AY. AY plus IY -2, -5, -3, -2. And I get AY equals 5.625 kilonewtons. And by inspection, I know that AX equals 0 because there's no externally applied forces in X. So there's nothing for it to resist. All right, so what makes the method of sections different than the method of joints is that we are going to, instead of solving joint by joint and going across, is we're going to make a cut in our truss. We're going to make a cut, and this works because the way equilibrium is, not only is our whole system in equilibrium, but every joint is in equilibrium. Every section of our system must be in equilibrium. So the way this works, I am interested in solving EF, EP, and LK. I'm going to make a cut that goes through those three. And what I end up with is I'm going to make a cut, and I can either look at the left side or the right side of that cut. I'm going to go ahead and look at the left side. And what I end up with is a system that looks like this. I don't have to really concern myself with all the individual trusses, just the system as a whole. So looking at the left side, I still have this AY, which is 5.65. Still have this -2, I still have this -5. And then I have LK, EF, and BP. So this is E. right? So I made this cut, and what I'm left with is the forces acting out of these cut sections, right? So I can effectively kind of go, right, what I've done is the same as doing this. Let's replace these with the forces. As far as the left side is concerned, it doesn't care about all those other joints over here. It just knows that, hey, those other joints act on me through these three forces here. So we've made this section, we've made this cut, and everything that's inside this blob, I don't really care what's going on internally. I just need to know what are the forces acting on it externally. So we have AY, we have these externally applied forces, and then the forces in the members that we cut. So now this is our new free body diagram. And we know it has to, these forces all have to add up to zero, these moments all have to add up to zero, because each section, each part of our system is in equilibrium. So now we can solve for these straight up. We don't have to solve for everything else. Really great. So I'm going to start by solving for the sum of the moments about point E. Right, we have these three unknowns. If I do the sum of the moments about point E, I don't have to worry about EP and EF for the time being. I can just solve for LK. And so I end up getting LK is going to cause a negative. So we get negative force LK, and that is a distance of 4. And then I get a +2 times 4 minus 5.65 times 8. And that ends up giving me LK equals negative 9.25 kilonewtons, which means it's in compression. Okay. And then I can, I went a little too far, so we're just gonna do my sum of my forces in Y. So that gets me 5.625 minus 2 minus 5 plus FEP times the cosine of 45. Right, because it's 2, it's 45 degrees. Or sorry, I guess sine 45. It doesn't actually matter with the 45 degree cosine and sine. So it's good notation. And so I end up getting that FEP equals 1.375 divided by sine 45 equals 1.94 kilonewtons. That's positive, so that is in tension. And finally, solve for FEF and use some of my forces in X. And I get FEP cosine 45 plus FEF plus FLK ends up being 1.94 cosine 45 plus FEF minus 9.25. The FEF ends up equaling 7.88 kilonewtons. That is in tension. So there, that's all it took. We're able to just cut right into the middle of our section of our truss, solve for the stuff we wanted to solve. We found out if it's in tension or compression, and then we were able to identify all those your force members. So under certain circumstances, the method of sections is a much easier thing to use than method of joints. We could have solved for those using method of joints and just gone across joint by joint by joint, would have taken us forever. So that is the method of sections in a nutshell. Hopefully that makes some sense. And as always, if you have any questions, want some clarification, feel free to message me, email me, or come to my office hours or set up a time to meet with me. So good luck.